although I'm going to repeat myself. So we are talking about elimination, where we are going to get rid of one of our two variables. All right. You can read the key concept part, but I'm going to jump right in example 4. So you want to look for the variable where you have two opposite numbers, because we're going to add the x's, the y's, and the constants, and we are going to get rid of one of the variables. Yes? We could, but take a look at my y's. My y's, I already have the two opposites. And this is what I would like for you to do. I want you to put a rectangle around the two opposites that you have. So you're saying, yeah, we're getting rid of the y's. Yes? I can't hear you. Well, you want to also add the x values. So 4x plus 5x is going to give me 9x, and 20 plus 8 is 28. So you just add everything in order, okay? So we are solving for x. Divide by 9, divide by 9. X is equal to 28 ninths. I can't believe this is the first example from the book, but it must be. So that is the x coordinate of the point where I have this solution. Aiden, put the phone away. Thank you. So I need to substitute that back into either one of my equations, and unfortunately neither one looks great. I'm probably going to substitute it back in that first equation. So I'm going to say 4 times my x value of 28 ninths plus 7y equals 20. So I'm just rewriting that same equation but substituting x in. Okay? Now, I have a fraction. I don't like to deal with fractions. And when you have an equation with a fraction in the denominator, there is a pretty easy way to get it all to whole numbers. And that is to multiply every term by the number in that denominator. So I'm going to multiply by 9. I'm going to multiply the middle term by 9. And I'm going to multiply the end term by 9. They are going to be larger numbers, but at least you don't have to worry about fractions, right? So this 9 and the 9 of the denominator are going to cancel out. 4 times 28 is going to be 112. Check my math on that. 4 times 28. Yes, I think that's right. And 9 times 7y is 63y. And 20 times 9 is 180. Now, the whole reason I'm doing this, Giev, is that I can get rid of the fraction. All right? So I need to solve for y. I only have that y variable. So let's subtract 112. Subtract 112. 63y is equal to 68. Divide by 63. Divide by 63. 63's cancel out. And we have y equals 68 63rds. Can I simplify that at all? No, I don't think so. But I do have my x and y coordinates now, so I need to write them as an ordered pair because this is talking about a point. So my x coordinate is 28 ninths. My y coordinate is 68 63rds. I need to put that in parentheses to show everybody, yes, this is an ordered pair. And Then I'm just going to put a nice big box so I can find it easily. So when there is one solution, what kind of lines are these again? Somebody other than Anno? Because he always answers. What kind of lines are these if there's one solution? Reagan. What kind of lines are these if I have one solution? So take your arms, show me some parallel lines. Okay, is that going to have a solution? One solution? Do they cross ever? No. Can you show me intersecting lines? Okay, is there going to be a solution in there? How many? One. So these are intersecting lines. Intersecting lines. All right, let's go below. Now, right here, we didn't have to multiply by anything because we already had our two opposites. Most of the time, you may need to multiply one or both equations by a number because you are trying to find two opposite numbers to add together and be eliminated. So let's take a look down here at the bottom. Let's look at this first set of equations. So look at your x terms, both of them. Now look at your y terms. Do we have any opposites right now? Survey says no. Boy, that was a weak no. Thank you. But that was weak. There is no opposites there, right? But I see here I have a 6x. And right above it, I have a 2x. If I wanted to make this go to a negative 6x, because 6x and negative 6x would be opposites, what would I have to multiply this 2 by to get negative 6? Negative 3. So we're going to multiply everything here by negative 3. And I'm going to rewrite it below. Emily. So, negative 5 times 3 is negative 15y. And 8 times negative 3 is negative 24. We are always adding them together because you want those opposites to be eliminated. So box up your opposites, cross them out, and now let's add the stuff that we have left. 2y and negative 15y is negative 13y. That is equal to 1 plus negative 24, which is negative 23. Divide by negative 13, divide by negative 13. Y is, negative divided by negative is a positive 23/13. This is not the whole problem, but we are really just focusing on eliminating one of the variables. Okay? Any questions on that first one? And I promise they are not going to be this yucky on the test. All right, let's go to the second one. I have a negative 6x plus 3y, 8x minus 9y equals 4. Look at your x values. Look at your x values. Do I have any opposites in the x values already? So I have negative 6 and 8. Are those opposites? No. Not yet. Right, but I'm looking for direct opposites that I can add together. What about 3y and negative 9y? Are those opposites? No, but I have a negative 9. What could I change this to get a positive 9? What could I multiply all of this by? Aiden, what could I multiply this 3 by to get 9? not negative. Yes, so multiply by 3, multiply this by 3, multiply this by 3. So 3 times negative 6 is negative 18x. 3 times 3 gives me that positive 9y. And 3 times 15, 3 times 5 gives me 15. So I'm just going to put a single line through that because that was the old equation. Now I have the new equation. I am going to box up these opposites and cross them out. 8x plus, well, it's a plus a negative. So 8x plus a negative 18x is negative 10x. Bring down your equal sign. 4 plus 15 is 19. Divide by negative 10, divide by negative 10. X is equal to negative 19 tenths. Another kind of yucky one. Focus on, we are trying to eliminate a variable. Okay? All right, when we come back from lunch, we'll do a couple more of those and we'll do a couple more examples and we'll call it a day. Okay? This is not the entire problem, okay? You should go back in and then substitute your y value, whatever value you ended up with, back into the original equation, and then you can solve for the other variable. And then you would write it as an ordered pair. Okay? Any questions on how to force something to cancel out by multiplying? Remember, you can do this for the x's or the y's. All right, so let's go down to example 5. This says we can also multiply both equations before using elimination. Although I don't know that that's necessary. Interesting. All right, so take a look at this. Do you see either the x's or the y's that look like they would be easy to cancel out? The 9s, yeah, you have a negative 9y and negative 9y. So they already have the 9. What could I multiply, let's say, this top equation by to make that a positive 9? Negative 1. Multiply by negative 1, right? And the only thing multiplying by negative 1 is going to do is change each sign, right? So negative 2x is positive 2x. Negative 9y, positive 9y. Negative 25, when you multiply by negative 1, becomes positive 25. Remember, we are adding, there we go. These are my opposites. So the y values cancel out. Negative 4x and 2x is negative 2x. And negative 23 and 25, Aiden, up here please. Negative 23 and 25 is going to be 2. Solve for x, divide by negative 2, divide by negative 2. X is equal to negative 1. But we need to solve. So we substitute that value back in either original equation. I would pick the one that has the smaller number, so I'm going to pick this one. And say negative 2 times x, which is negative 1, minus 9y equals, can't even tell, is that a negative? Yes, it is. Negative 25. Negative times negative is a positive 2 minus 9y equals negative 25. Subtract 2. 2's cancel out. Negative 9y is equal to negative 27. Divide by negative 9. Y is equal to 3. Is that enough for your final answer? No. X is -1, Y is 3, but I should write it as an ordered pair. So -1, comma 3, make sure you put the parentheses in and write it as an ordered pair. So if I have one solution, what kind of lines are those again? Intersecting. Or as I think I put on the first day, which was a Friday, interesting. No, they're not interesting lines, they're intersecting lines. Interesting, yes. All right. I think we can do one more. We're going to do one more. You guys are doing really well. I appreciate it. This says elimination where there is not exactly one solution. That means either there's going to be infinitely number of solutions or no solution. Okay? So take a look at these two equations. I want to eliminate either the x's or the y's. JL. Is there something I could multiply the second equation by to get rid of either the x's or the y's? Okay, 2. Which one? What am I multiplying? Well, I'd be multiplying everything by 2. 2 times 6 gives me 12. 12 and 18 are not opposites. 2 times 7 is 14, and that's not an opposite either. So I think we need to go higher than 2. We need to go to 3, and not just 3, but a -3. Does that make sense? Because -3 times 6 gives me -18. We want to try to force those opposites. All right, so I'm going to rewrite it down here. -3 times 6 is -18x. -3 times 7y is -21y. And -3 times 2 is -6. So I'm going to put a single line through that original equation so I don't get them mixed up. Then add them together. And here are my two opposites. One has a positive sign, one has a negative. They have to be opposites when you are canceling them out, okay? Those cancel out. I have 21y plus a -21y. What does that give you? 0. So sometimes we would just cross them out, but I got to have something on the left-hand side of this equation. And what's 14 and -6? 8. Is 0 equal to -8? No. So what does this mean for my answer? No solution. That's right. If it is not true, that means no solution. So what kind of lines are these two equations part of? Parallel lines. Parallels, parallel lines. Okay? So I think we can stop there. You should be able to get a good portion of homework 3 done. Okay, are you still waiting on those word problems? Again, if you have not done homework 1, homework 2, get those done first. Then work on homework 3. I think I mentioned this yesterday. The Canvas activity for 9/8, that is still current. And you can do that until Friday at midnight. We are taking a week off from the weekly Canvas activities, though, okay? I'm just laying on my desk. Thank you. All right, so Everybody, you should be working until the bell rings. This is still class time. Use this time. Aiden, you need to take your stuff back out. This is still class time. You need to be working on homework.